Welcome to the Week 8 discussion. This week we're going to discuss the bullwhip effect. This is a fairly simple concept, but basically going to cover a few things. I'm going to cover what the bullwhip effect is, illustrate how it works, and then describe how it affects supply chains, various relationships, and then I'm going to talk about how to mitigate it and various factors that influence it within a supply chain. So, what is the bullwhip effect? The bullwhip effect is a phenomenon in which minor fluctuations in demand, which occur at the end user or the users closest to the end of the supply chain, create magnifying demand variations. So, and this demand variation is felt at varying levels within the supply chain, and it's important to understand that the demand variation is caused by people's reactions to perceived variation and not by the demand by the customer itself. One thing in particular is each element within the supply chain will see, excuse me, will see differing levels of demand variation, which is important. This is one of the key concepts behind shared demand forecasting to reduce the differences in demand variation within a supply chain. So as I said here, each entity within the supply chain feels a different level of demand variation, which is important because as it gets amplified, those furthest down the supply chain, like the manufacturers, they will feel a more magnified sense of the bullwhip effect than others, which causes a sort of a gaming effect at times where they start to game the numbers. I'm going to go through that in a bit, which causes even more variation. So the retailers feel the least effects of the bullwhip effect because they're closest to the customer. And in many cases, the reaction to bullwhip effect by retailers is a main cause. Well, it's not a main cause, but is one of the causes of the bullwhip effect's magnification throughout the supply chain. So here's a picture that I created for showing how the bullwhip effect. So as you can tell, as the product moves, the demand variation, as it is felt, is opposite to the movement of the products. Once again, the bullwhip effect begins with the customer demand. Excuse me again. Starts with the customer demand, and it echoes from the retailer whose reactions to the customer, or sometimes even not even reactions to the customer. As we're going to see in a bit, the retailer can actually create these oscillations without the customer's behaviors being involved. For instance, retailer, like in the module lecture this week, the retailer can create this oscillation by creating a promotion, sales promotion, in which they purchase extra stock, but they don't communicate with the other actors. Because of imperfect information, the other entities will feel that this is a change in demand and will change their demand forecast accordingly. Now, as we've defined earlier in earlier weeks, things like rebates and discounts can create artificial oscillations by the customer, where people front load their demand, where they buy early or they buy late, right upon the price, which is why everyday low pricing is usually recommended. But nonetheless, you just realize that the retailer can actually create this bullwhip effect without even involving the customer, without involving the customer's demand. So the effects on the bullwhip effect on the supply chain, there's various. Here's a few that I've found in various resources I have. The first one: excessive inventory investment. Once again, don't forget your safety stocks are tied to your demand variation. So if the demand variation is felt that it is increased, excuse me again, this will force the, well, it doesn't force, but this may cause the entity in question to increase their safety stocks, for instance. For instance, in the case of demand forecasting, excessive demand may alter the demand forecast such that it may create a larger demand forecast, which in turn creates larger investment. Poor customer service. Poor customer service can be caused by not allocating enough people to demand, or allocating too many people, and also not having the resources available because they've been dedicated elsewhere. Lost revenues, erroneous capacity planning, and ineffective transportation and protection scheduling. This all has to do with chasing false demand. So if you schedule 1,000 goods to be shipped and the customer only orders 50, you've scheduled too much transportation. So just an example. Okay, the relationship between lead time and the bullwhip effect. Lead time increases. Whenever lead time increases, this causes procurement and manufacturing delays. Many people feel that a lack of information sharing is the primary culprit of the bullwhip effect. And actually, it is an important culprit, but it's not the main culprit. The main culprit is lead time. I've seen various videos, and I've actually read an interesting article on this where they run this scenario with perfect information, and yet the bullwhip effect still occurs. Whenever you have increased lead time, the effect is multiplicative. Sorry about that. So like, for instance, if you go from 1 to 2, the oscillations in the supply chain can be 4 times. So just for example. So when you have a lack of perfect information or lack of good forecasts, the effects are additive. This is because of the additive effects of lead time upon each entity. So now, increases in variation at each stage is multiple. Okay, I already covered that. So perfect information reduces but does not eliminate the bullwhip effect, because the compounding demands caused by lead times and forecasts will still cause over and under ordering. This is related to the panic buying. If you have increased lead time, people will start to hedge their bets to ensure that they have enough product. If the lead time increases, we covered this in week 1 or week 2. If lead time increases such that they can't reliably feel that they can, reliably get the product, then they will increase their orders, which in turn creates bullwhip effect. Because once they get their orders, if they end up getting everything that they wanted, well, then all of a sudden they will just cut down their order in the future. So factors influencing bullwhip effect. Lack of visibility along the supply chain. This is the main benefit of collaboration is to increase the visibility across the supply chain, so everyone sees the exact same demand variation as the front. Okay. Now you will still have demand variation because each person in the supply chain acts independently, but it will reduce. Increasing visibility will reduce bullwhip effect. So independent demand forecasting amplifies order variability. So if you have independent demand forecasting, obviously each independent demand forecast will create independent orders to chase that demand, so that it amplifies order variability. So, which in turn amplifies bullwhip effect. Long material and information lead times, multiple supply chain stages. These are all compound the problems with bullwhip effect. That's why a lot of supply chains try to reduce the number of stages in there in the supply chain. One, it reduces lead time, but also it reduces the ripple effects of things like bullwhip effect and a lack of pull signals. Pull signals are basically, this is from pull supply chains, where a product is not created until it is pulled from the vendor. In this instance, this results in push tendencies favoring favoring forecasting. Sorry, that's a typo on my slides. So if you use a pull signal, the demand is only felt when a product is required. Therefore, that will reduce the bullwhip effect within the supply chain. Order batching. This goes hand in hand with the gaming of the system. When people order in like 1 month's worth of product or a week's worth of product, this creates a lumpy demand. And the larger the lump, the larger the order, like 2 weeks versus 2 weeks versus 1 week, or 3 versus 2 weeks, the larger this lump occurs. So order batching is a major contributor to bullwhip effect. Pricing discounts and promotions, like I mentioned earlier in the class, and also just earlier, promotions and discounts artificially distort demand without the other entities within the supply chain knowing it, which creates a customer buy forward behavior. And this is one of the official names for panic buying. If a customer feels that this is a short time, one-time sale, they're going to bulk up. I mentioned this with the Campbell's Soup case study, where Campbell's Soup would put things on sale, people would bulk up and then pretty much not buy soup for the rest of the year, which created all kinds of problems for Campbell's Soup. And then gaming behavior. There's a systems theory which states that when scarcity occurs, people will increase their order to guarantee that they get what they need. So orders increase with high actual demand instead of low actual demand. So as the demand for a product increases, people will increase their orders in an attempt to get, quote unquote, their share. So this creates exactly the opposite of what you think. Customers increase orders when shortages occur, and decrease or cancel orders once the shortages disappear. Once they get all their stuff and the shortage goes away, they just quit buying it because they already have what they need. Or they wait until the next sale occurs if they feel that the customer feels that the sale is going to return. So typical reactions to bullwhip effect. These are just a few here. Overacting to backlogs. This is, if you play the beer game, this is illustrated very clearly. As a backlog occurs, those closest to the customer will end up ordering. They may order more, but as you go further and further away from the retailer, you'll see the backlogs get bigger and bigger. Withholding orders to reduce inventory. Well, that happens once the retailer gets enough and they begin to reduce inventory if they have too much. Hoarding can occur. This is due to anticipated price increase or upcoming promotional sale. The anticipated price increase occurs when customers hoard. Upcoming promotional sale is retailer hoarding, when the retailer is getting to prepare for a promotional sale. So shortage gaming, which is called panic buying. Inaccurate or inflated demand forecasts. We covered earlier in the class how they said, hey, would you recommend an inflated demand forecast? What do you think would be the benefit of that? And there were some good answers, to be fair, but when you inflate demand forecasts in a bid to get someone in the supply chain to do something for you, you create an oscillation, which amplifies further down. So inflated or deflated demand forecasts can be very dangerous in this regard. So in attempting to meet periodic production or sales quotas, and this happens quite a bit, manufacturers have break-even points Sometimes they have capacity break-even points where they have to make so many products. I mentioned about Ford in the early 2000s, 1990s, where they had capacity problems where they renovated such that they had to build so many cars a month to break even. Well, they began to make extra cars to break even, quote unquote, but they ended up having too much capacity, too much inventory, which as a result dropped the price down, which diluted their profitability. And also, once it got flooded, they kept building cars at the same pace, which basically they were slowly choking themselves out. Um, Luckily, they were able to fix that, but that's a pretty major concern. So, to mitigate bullwhip effect, anything that reduces lead times will help reduce the bullwhip effect the most. So once again, lead times have a multiplicative effect on bullwhip effect. Um, of course, shared point of sale and electronic data is very helpful. Once again, that has an additive effect. So anything that involves sharing data like vendor managed inventory, VMI, is very helpful. Collaborative planning. Yeah, VMI is down there. So improving shared forecasting is very helpful because it tells people what's going on, especially when you communicate sales and rebates, obviously. Reduce batch incentives. There's a common practice to give rewards for bulk orders. Well, this can cause problems. I mentioned a few weeks ago, if you're able to reduce the number of batches, reduce the size per order, this allows you to have a better control over the inventory. It also gives you a better control over the demand. So when a person orders for a month, you may say, hey, look, I'll give you the same price for a week as you do for a month. Sometimes it's better to give them better pricing for a week to a month versus a month, depending on the product, obviously. Cross-docking and consolidated order shipping, this reduces lead time, which is key. And increased price stability through having everyday low pricing, one price for everything. This is common. People sometimes nag on people like Apple for not breaking down the prices. But this is one of the reasons why they don't bring their prices down frequently, because they want to have control over their supply chain. Oh, excuse me again, over the supply chain. So that is pretty much it. Bullwhip effect is a fairly simple concept. It has complexity within the concept. Just remember a couple key concepts. One, remember that the ripple effect is felt worse the further away from the retailer or the customer that you go. Okay, that's important, which is opposite to the way the product flows within the supply chain. And also realize that lead time is the main culprit. So reducing lead time gives you the best benefit to reducing bullwhip effect. Obviously, if you have a low lead time, reducing lead time further may not be as good as providing perfect information. Perfect information is always very useful. Sometimes it's hard because of the competitive nature of supply chains. But if you can remove the independent incentives within the supply chain, this is your best bet. So that is all for this lecture. Please feel free to provide comments in the class and let me know how you guys feel. If there's any questions, please let me know. Thank you very much and goodbye.